Hello students, welcome back to today's class on basic geometrical ideas, and in today's class we're going to have a small practice session. I'm going to give you some questions as well as some time to break all the questions, and very easy chapter and very easy questions. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what's the first question that we're going to discuss in today's practice session? Right, a line segment has no length. Say true or false. Has no length. Line segment. So please carefully discuss, carefully tell me about line segment. What is the answer for that? We discussed what is a line, what is a ray, what is a line segment. So you need to understand which has a length and which don't have any fixed length. Okay. So when we discuss about a line means which is a never ending from both the sides. It has no starting point and no ending point. So can you tell what is the length? If I say 5 centimeters, some other person will still further expand and tell that it is 10 centimeters. One more person will come, extend it more and will say 1 kilometer. And I'll come again to extend it more to say it is 100 kilometers, 1000 kilometers, and it is a never ending. That means it has a no fixed length. It has no fixed length. Okay. This is about line, but the question is asked about line segment. You should be very careful with that. You should be very careful with that. It is a line segment. What is a line segment? Segment means it's a part of a line. Segment means it's always a part of something else. So out of this complete line segment, if you fix 2 points, let's say P and Q, this PQ this PQ is the line segment. Okay, so this PQ bar, we represent like this. PQ bar is a line segment. This is a line segment. Okay, and it has a fixed line. It has a fixed length. It has a length, let's say 10 centimeters or 20 centimeters or 1 kilometer, 100 kilometers, whatever it is. How big or how small, it has a fixed length. It has a fixed length. So what we say, a line segment has a no length. It is a false. It has a length. It has a length, so that's the reason we say it is a false. Okay, so moving forward for the next question, the line AB bar. Okay, the line AB bar is the same as that of a line BA bar. Okay, some adjustments issues. So it is a BA bar. I'll write it again. AB bar is same as that of the line BA bar. The point is, are these two equal or not? The line AB bar is same as that of line BA bar. Say true or false. I said you, this notation says that it's a line, it is not a line segment. If we have AB bar, it is a line segment, but if we have AB and two lines like this is a line. And for a line we said there is no starting or ending point. Okay, so if I write a line like this, A and B, you start from this direction, go to B, or from B to A, you don't have any starting point or any ending point. So from A to B or B to A, you are representing the same line. You're representing the same line which is extended in both the directions till infinity. So we can say that the representation AB bar or BA bar, not bar actually, AB and BA, the lines AB and BA represents the same line, is same as that of the line BA. So is it true or false? Definitely it is a true. It is a true. But it is not true for ray, if you can observe. For a ray which has a starting point but has no ending point, for a ray, we say AB ray and BA ray both are not the same. Why? Because it is starting at A and moving towards B. It is starting at B and moving towards A. These two are not exactly the same rays. Those two are different rays. So for a line, although these two are same, for the rays, these two will not be the same. Okay. So moving ahead, a dash has only one end point. Only one end point. See, if I talk about a line segment, you know, it has both end points. It has both end points. Line segment. If I say if I say line has no fixed points, no starting points, no ending points, nothing. It is universally moving towards right as well as to the left, everywhere, right? It is not stopping anywhere. But one endpoint is what we just discussed, ray, which has a starting point or an endpoint, whatever you say, and the other side it is moving till infinity. So the answer for that will be ray. A ray has only one endpoint. A ray has only one endpoint. So let's move forward for the next one. Dash line or lines can be drawn passing through two given points. Dash line or lines can be drawn passing through two given parts. That means how many lines? How many lines can be drawn passing through two given points? Let's say this is one point A and this is another point B. So now the point is, from these two points, how many lines can be drawn? Lines, it's not about curves. It's not about curves. We are discussing about the lines. You can see here, we can draw only one line passing through these 2 points. Only one line segment can be drawn using these 2 points. Okay, so the question is, how many lines? It is only one line we can join these 2 points. If it is a curve, okay, A and B, you have infinite many curves. You can have this one curve, okay, the second curve, the third curve, okay. So fourth curve, fifth curve, sixth curve, seventh, eighth, ninth, tenth, and hundreds and crores and lakhs. You can have simply infinite curves touching from the 2 points. But for example, for the considering a line, we can have only one single line, right? So the most easy thing. And the next question, quadrilateral is a polygon formed by dash number of line segments. 1 line segment or 2 line segments, 3 or 4, 5 or 6. Quadrilateral, we discussed what is a quadrilateral. Quadrilateral is a polygon formed by 4 sides. Simply, you can take a square or a rectangle. This is a quadrilateral. This is a quadrilateral. So the point is, how many line segments are involved in this one? How many line segments? So this is the point A, this is the point B, this is the point C, this is the point D. A, B, C, D. AB is one line segment, BC is the other line segment, CD is the other line segment, and DA is the other line segment. So there are 4 line segments. There are 4 line segments. Quadrilateral is a polygon formed by 4 line segments. Clear? Alright. So moving ahead, what is the next one? We're going to see curve in which the starting point and ending points do not meet is called dash curve. Once again, let's try to understand. Curve in which the starting point and the ending points do not meet is called, for example, I have, do not meet starting and ending points. Okay, so point is here. Okay, let's say ending point is here. The starting and ending points do not meet. That means these two are not the same. So it can be curved like this, which is called an open curve. Open curve. What is other type of curve which we are discussing? We have something called closed curve, where, for example, we are starting at this point. The starting and the end point both are same. The starting and the end point both are same. So these type of curves are called closed curves. So now the question is, starting and ending points do not meet. Starting and ending points do not meet. So it is called open curve. It is called open curve, right? Curve in which the starting point and ending points do not meet is called open curve. Okay, so moving ahead. All radii of the circle are equal, say true or false. All radii. What is the meaning of radii? It is a plural of radius. If you have 2 radius in the circle, we say the radii. The question is, all radii of the circle are equal. Is it correct? So if you take a triangle, sorry, if you take a circle, we have a center point, and the distance to the curve, this is called radius, small r. We can represent small r. So we have one more radius, radii, radii. Okay, so the next radius, the next one, are all these same? Yes, it is. They are of equidistant points. Okay, so all the radius or all the radii are equal in length. So we can say that true or false. Yes, it is a true. It is a true. Okay. So the next question we are having, diameter of a circle is 2 times of what? Diameter, if you can remember, we discussed in last class. Okay, so we have a circle like this, and let's say we have this one as a radius, and the diameter is a line passing through. The diameter is a line. I'll draw with another ink. Diameter is a line passing through 2 ends and the center of the circle. 2 ends and the center of the circle. So this length, for example, this is O, this is A, this is B. OA is R, the radius, as well as OB is also radius R. OA is radius and OB is radius. OA is radius and OB is radius. Okay. So we can say that radius are equal. So the complete diameter length, let's say D, is equal to R plus R. It is 2R. The complete D is equal to R. Okay. So the diameter of a circle is twice the radius. Diameter of a circle is 2 times the radius. Right. So moving ahead, dash is the largest chord. What is chord? Once again, what is a chord? For example, we have a circle like this. So any 2 points, line joining any 2 points on the circle is a chord. That is a chord. We have more chords. Okay, this is one of the chord joining 2 points. This is one chord joining these 2 points, right? This is one chord joining these 2 points. In that way, the largest chord will be the chord passing through the center. And you can say that the line passing the center and touching 2 corners, 2 ends. Okay, so that is called a diameter. So diameter, the answer is diameter is the largest chord. Diameter is the largest chord. Okay, so moving ahead, a dash of a circle is a line segment at the one end point in the center and other end point on circumference. A dash of a circle is a line segment at the one end in the center and the other end point on the circumference. Let's try to understand what is that. It's a very simple thing, but you may not be able to understand the framing of that. But if you read carefully point to point, word to word, then it will be very simple. What is that we're having? A dash of a circle is a line segment at the one end point in the center, and the other point on the circumference. This is a one end on the center and the other end on the circumference. So this OA is nothing called radius. Okay, so radius of a circle is a line segment. It is a line segment at the one end in the center and the other end point on the circumference. That is called radius. Okay, so moving ahead, explain concentric circles with diagrams. What do you mean by concentric circles? Concentric. So the name itself says that centric, that means they are having the same center. Circles having the same center are called concentric circles. Okay, so this is a center, concentric. This is one circle and center. Okay, if we have one more circle whose center is again the same point. These type of circles are called concentric circles. we can have many other circles. Okay, we can have many other circles having the same center. So all these triangles also, all these circles are called concentric circles. Concentric cycles. Okay, so concentric cycles, so circles, we can say this is a diagram. So moving ahead, define the following intersecting lines. What do you mean by intersecting lines? Intersecting lines means lines which touch at one point. So this is one line, this is one line. These two will meet at one point. So those two lines are called intersecting lines. Parallel lines, this one line and this one line, which is moving in this path which will never meet. Parallel lines will never meet. Such type of lines are called parallel. The lines which never meet are called parallel lines. Next one, concurrent. What do you mean by concurrent? If you are having two intersecting lines, if you have one more line passing to the same point, one more line passing to the same point, one more line, all these lines are called concurrent lines. All these lines are called concurrent lines. Next, collinear points. Collinear means the points lying on the same straight line. So this is a line. So if you have a point here A, point here B, point here C, we can say A, B, C are collinear points. We can say all these points are collinear. Point A, B, C are collinear. We can have point D. We can have point E. All these are collinear points. All these are collinear points. Okay. So the next one. Okay. So let's try to understand what is a triangle. You know, triangle is a polygon. It's a closed figure with how many sides? Let me draw a triangle. So this is a triangle. You can see 1, 2 and 3. So triangle is a three-sided polygon. Triangle is a three-sided polygon. Next, quadrilateral. Quadrilateral is a four-sided polygon. Heptagon. Heptagon means 7. Hep means 7. Okay. So is it seven-sided? I don't think so. I have a seven-sided. Okay, let's try to come back again. Okay, pentagon. Pentagon is a five-sided polygon. It is a five-sided polygon. Octagon is eight-sided polygon. Hexagon is a six-sided polygon. And we don't have other option for heptagon. Heptagon is seven-sided polygon. And 10 sides we call it as a decagon. 10 sides we can call as a decagon. Right, so this is how the names are given. Once again, penta means 5. Penta means 5. Pentagon, 5-sided. Octa means 8. Octa means 8. Hexa means 6. Okay, hepta means 7. Quad means 4. Quadrilateral. Tri means triangle, 3-sided. Okay, so these terminologies are very important. Moving ahead, draw the following: circumference of a circle, segments of a circle, semicircle, sector of a circle. So let's try to draw a circle and then let's try to see what are all the things. Okay, so let me draw a circle first of all. So let's see, this is a circle. Okay, circumference, that means the complete blue part, the complete blue line. Okay, that curve is circumference. So it is done. Now we need to draw about a segment. So draw any line like this. Okay, so this is one segment and that is the other segment. They can be equal, they may not be. Right, one is major segment, one is a minor segment. This complete big thing is called major segment. Major segment, and this is called minor segment. This is called minor segment. What else we are having here? Semicircle. Semicircle means which passes through exactly middle. That means half. Semi means half. So draw a diameter, and this part, this entire part, this is one semicircle and this is one semicircle. So this part is one semicircle, green color, and this part is the other semicircle. So we have two semicircles. We have two semicircles. And the next one, sector. Major and minor sector. Okay, so sector will come from arc. So let's take some part of the arc. Let me draw one more triangle, one more circle. So if you take one arc here and if you join this one, so we get a part of that. Okay, so this is the first part, the second part. So we have this called as sectors. Okay, the part of the circle. If it is length, if it is bigger, we say major sector. If it is smaller, we say minor sector. Same way like major and minor segment, we also have major and minor sectors of a circle. Okay, so moving ahead, circumference, segment, semicircle, sector of circle is done. So moving ahead, whatever we're having, so say true or false. Two lines are parallel if they do not meet even when produced. Yes. Two lines are parallel if they do not meet. Yes, these two lines will never meet even when produced. Produced means you extend in both directions. You extend, that is what produced means. They never meet. Yes, it is true. The first one is true. Two parallel lines are every way the same distance apart. Yes. So the distance between these two lines will always be the same. The distance between these two lines will always be the same. So the next question is also true. And what about the next one? If two line segments do not intersect. If two line segments do not intersect, they are parallel. If two line segments do not intersect, so two line segments are there which do not intersect, they are parallel. Yes, all these things are the same thing for parallel lines. These are different properties or the points of parallel lines. Right? The next one we're having, if two rays do not intersect, they are parallel. Two rays do not intersect. Right, so they are parallel. They will never intersect. True. A line between two parallel lines is always perpendicular to each other. A line between two parallel lines, is always perpendicular to each other. So if we have a line like this, it is not perpendicular. It is not perpendicular. But sometimes if the line is like this exactly, so we say this exact shape is perpendicular. What do you mean by perpendicular? Perpendicular means if you have one horizontal and one vertical, so whatever the angle here, whatever the structure we are getting here, these are perpendicular. Simply, you can see the corner of your house, your walls. Two walls, right? So two walls will intersect exactly in a perpendicular manner. So that is how perpendicular. So line between two parallel lines is always perpendicular to each other. So it's false. It's not always true. It depends on the orientation of the new line. Okay. So I hope you understood all these questions, all these practice questions, and I hope you understood well about the basic geometrical ideas. In the coming classes, we're going for the next topic and we're going to learn more beautiful concepts like this, right? So thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today we'll be discussing about light. A very basic topic, yes? Okay. My name is Shashan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. The first question is this, very simple discussion. Why can't we see in the dark? Basically at night. At night we cannot see things clearly. Why? You know the answer. That is, there is no light. So to see anything we need what? We need light. So the question that we can ask next is, then how do we see objects? Obviously using light. But how does light help us in seeing objects? How? I mean, think about this. Is light the only thing that is required? What do you think? Is light the only thing that is required? No. Our eyes should work, our brain should work, many things that have to work. Right, so how exactly do we see objects? We'll go into that. But here we have an interesting animation, you can clearly see that. That clearly shows that when there is light, you can look at objects. When there is no light, you cannot look at objects. Yes or no? Interesting animation, yes? Okay, good. Let's continue. So here look at this, how do we see objects? So here there is a girl, we can see her, right? So she wants to look at both the bulb and the flower. She has to look at the bulb as well as the flower. In that case, let's see. First, she is looking at the bulb. So when she is looking at the bulb, what happens exactly? What happens is, what does bulb do? Bulb will give out light. Bulb will emit light. Bulb will produce light. So light from the bulb will reach her eyes. So if I am looking at a bulb, from the bulb light will come into my eyes. It will go into my eyes, and then after that it's our body. Our body will take care of it. But the basic requirement is light from the object should reach us, should reach the observer. In this case, it should reach the girl's eyes. Simple. So she can directly look at the bulb. So light from the bulb directly reaches her eyes. Okay, that's good enough. But how can she look at the flower? Because flower is an interesting case. Now when there is no light, let's say it's completely dark. At night, midnight, there is no moonlight, nothing. There is no bulb, no tube light, nothing, no source of light. The room is completely dark. And if there is a flower, can you see it? The room is completely dark, but there is a flower. So can you see the flower? You cannot. Right? Because there is no light. Right? Now imagine this. Let's say in the same room, there is a flower and there is a bulb that is glowing. Then can you see the flower? Yes. But how? How does light behave in that case? In that case, what happens is, who is producing light? The bulb is producing light. So from the bulb, light will first fall on the flower. Light will be incident on the flower. Light will fall on the flower. And then from the flower, it will bounce back and it will reach the observer, in this case, the girl. In the previous case, when we are talking about the bulb, from the bulb, light directly comes to us. But in the case of the flower, light will first fall on the flower. From the flower, light will come to us. And that's when we see the flower. Understood? So ultimately, light is something that helps us to see. Right? So what is the definition of light in that case? The definition of light will be this. Light is a form of energy that enables us to see objects. It will enable us. It is only because of light that we are able to see objects. Simple definition. Yes? Okay. And we see things, right? When either of them should happen, two cases. Light emitted by them enters our eyes. For example, a bulb. From the bulb, light is emitted, it will reach our eyes and we can see the bulb. Or else, light bounced by them enters our eyes. The light bounced by objects enters our eyes. Best example, for the first case, it is a glowing bulb. In the second case, the flower, that which we discussed until now. That's when we can see the objects. Either light should be emitted by them and light should directly come to us, or the object should bounce back the light. Good? Okay. That's an interesting animation. You can clearly see that. Okay. Understood? This is light. Okay. Now let's continue. Now let's look at two kids talking to each other. So let's call them as Tanvi. Let's call her as Tanvi. And let's call this boy as Anvit. Tanvi and Anvit. And let's listen to what they are talking to each other. So what is Tanvi saying? Tanvi is saying, wait. Wait, did you notice that there are two types of objects? Tanvi is asking Anvit, did you notice there are two types of objects? Anvit says, two? Yeah. What does Tanvi say? Tanvi says, yes, the bulb directly emitted light. So one type of object is directly emitting light, and then Anvit catches on and Anvit says, Anvit is intelligent. So Anvit says, this second type of object, the second one would be the flower which did not emit its own light. That means again Tanvi continues. The flower just reflected the light falling on it. The flower just bounced back the light falling on it. All the points that we discussed. Yes. So, Tanvi continues. So, one type of object produces its own light. Bulb will produce its own light. Whereas the other type or the second type does not produce light but reflects the light from others. Yes or no? One object produces its own light. The other object does not produce its own light, but it will reflect, it will bounce back the light falling on it. Simple. Yes. So based on this, we define two different type of objects. One we call it as luminous objects, and the other we call it as non-luminous objects. So what are luminous? They produce their own light, or you can say emit their own light. What about non-luminous? They don't. They do not produce light. They do not produce their own light. That is non-luminous object. Simple. Okay, I'll go into them in much more detail. We'll go into a few examples also. So first we'll go into luminous objects. Look at this. Objects that give out or emit or produce light of their own are called luminous objects. They produce their own light. Right? Example, bulb will produce its own light. Sun, the best example. It will always produce light, it will always emit light, and because of sun, or exactly speaking sunlight, we can see everyone or everything around us. Sunlight, sun, luminous. Candle produces its own light. It's also luminous. So luminous objects produce their own light. In fact, there are many other examples. Even a phone, a mobile phone, a laptop screen. Those are also what? Those are also luminous objects. A torchlight, luminous objects. Firefly, luminous object. Fire, luminous object. Understood? All of them produce their own light. Good? Okay. What about non-luminous then? These are the objects. Non-luminous these are the objects that do not give out or produce or emit their own light. They do not do that. Do not is the important word. Then what do they do? Or else how can we see them? That flower example. If I have to see the flower, bulb should be switched on. You have to see the flower, bulb should be switched on. That means a source of light. Source of light is the object from which light comes. So a source of light, which means a luminous object, is needed for a non-luminous object to be visible. So to see a flower, we need a bulb or sunlight, anything like that. So to see a non-luminous object, you need an object that will produce light. That means you need a luminous object. So again, read it. A source of light or a luminous object is needed for a non-luminous object to be visible. For a non-luminous object to be visible. Clear? Yes? Okay, some of the examples. A table, a wooden table. A wooden table. It is what? Non-luminous. It does not produce light. A tree. Non-luminous. A boy. Non-luminous. I mean, forget about boys. I mean, all the human beings. Am I producing light? No. Are you producing light? No. We human beings do not produce light. That means we are non-luminous. We are non-luminous. Good? So understood the basic difference between luminous and non-luminous. Luminous, they produce their own light. Non-luminous, they do not produce their own light. Okay. So now when we look at nature, when we look into nature, some interesting bodies that we observe is, one is sun in the sky. What all can we see in the sky? Sun, clouds obviously. Then during the night time you can see stars as well as moon. You can see stars as well as moon. So the question is, are stars luminous? Yes, because stars shine, they produce their own light. But another interesting question will be, is moon luminous? Now look at what's happening and then you tell me, is moon luminous? Look at the animation here. What's happening? Light from the sun is falling on the moon, and from the moon it bounces back onto earth. That is what is happening here. From the sun, light is falling on the moon. Moon will reflect or bounce it back onto earth. So is moon producing its own light? Is moon producing its own light? Everyone, what do you think? Is moon producing its own light? No. So the question, is moon luminous? No. Moon is a non-luminous object. Or I'll say moon is non-luminous. Understood? Moon is non-luminous. Clear? And you might have noticed this is a very important point, by the way. Moon is non-luminous. So how is moon visible? Moon reflects the sunlight. When I say sunlight, light from the sun falling on it. Okay? And moon obviously is what? Non-luminous. Okay, that point we understood. Now comes an interesting question. Whenever you look at sun, whenever you look at the sun, whenever, morning, evening, night, anytime, what is the shape of the sun? Night obviously it's not visible, but whenever the sun is visible, what will the shape of the sun be? The shape of the sun is always a circle. Shape of sun is always a circle. But shape of moon, is it always a circle? Shape of moon, it is not a circle. It can be a circle on full moon. It can be completely empty, completely black on a new moon, Amavasya. It can be half, it can be a crescent. Yes or no? It can be in any shape. It can be in any shape. Yes or no? That means there is something that's happening. What's happening? Look at the question. That's why it is interesting. What is the question here? If moon were luminous, assume that moon is emitting its own light, then would it still have different phases? These are different phases, as you can see. 1, 2, 3, 4. Because in 1, only this much part is visible. In 2, half part is visible. In 3, more than half is visible. In 4, complete moon is visible. Again, I can take 5. 5 again, complete is visible. 4, not complete. Let's say this much. Right? 6, 7 half is visible. And 8, it's something like this. You can see there are different phases of moon. Can you notice it? Now the question is, if moon were luminous, if moon emits its own light, would it still have different phases? What do you think? Yes or no? Imagine that moon is emitting light. Moon is luminous. And then you tell me, are the different phases possible? Yes or no? What do you think? The answer is no. Very simple. See, if moon is luminous, this part of the moon should also be emitting light, and that part should also be visible, but this part is not visible. That means the phases of moon, they prove that what? Moon is a non-luminous object. Moon is what? A non-luminous object. Understood? Okay, that's good. Wonderful. Next. So now we understood that objects are of two types, luminous and non-luminous. Good enough. But there is another type of division, another type of classification. What are they? That is based on whether they allow light to pass through them or not, or whether you can see through them or not. We divide them into transparent objects, translucent objects, and opaque objects. So how many classifications do we have? 1, 2, 3. Three classifications: transparent, translucent, and opaque objects. Understood? Okay. Now, so let's go into them one by one. What do they mean and all? First comes transparent objects. This is like glass, clear water. What do? You can clearly see through them. Look at the image. Can you look at the floor? Not the floor, the bottom of the lake. Can you look at the bottom of the lake clearly here? We can. We can clearly see through water. I mean, in fact, it appears to me that the boat is flying. Is it flying? No. It is on water, but the water is so clear that you can see the bottom. That means That means you can see through water, or light passes through water. So transparent objects are those objects that allow light to pass through completely. You can clearly see through them. Right? You can clearly see through them. Can see clearly through them. Examples: glass, clean water, not muddy water, not polluted water, no. Clean water, plastic, air, etc. Air is an interesting thing. Air is transparent. I am able to see through air, yes or no? Whatever is in front of me, I am able to see through air. Even you are able to do that. Air is not, you are not able to see air, you are able to see through air. If you are able to see through something, that means that object is a transparent object. It is what? A transparent object. Okay, so I'll give a simple comparison for you. We'll discuss after we go into translucent. Then we'll go into translucent, and the image describes everything regarding translucent. Look at this. Here we have a butter paper. Remember the word butter paper because it's one classic example of translucent object. Now the question is, can you see through the butter paper? Yes. But can you completely see through it? No. The hand is blurred. The hand is not clear. That means not all the light passes through translucent. Some light passes through translucent, some does not. So here translucent objects allow light to pass through partially. They allow light to pass through partially through them. Can see through them. We can see through translucent objects but not clearly. So it's like in between transparent and opaque. Example: butter paper and fog. Understood? Remember the examples. For each and every type of object, it is important that you should be able to give a few examples. Okay? Okay. Then we understood transparent, we understood translucent. Now comes opaque objects. What are they? They do not allow light to pass through, and thus we cannot see through them. For example, door, walls, humans, etc. Can you see through me? Can you see what is beside me, what is behind me? Can you see what is behind me? No. You cannot see through me. That means I am not allowing light to pass through me. I am opaque object. So you are also an opaque object. There are many opaque objects. For example, this screen. Can you see what is behind the screen? If I am placing my hand behind the screen, can you see it? No. You cannot. So the screen is opaque object. Screen is opaque object. Okay? Good. So now, if I go into transparent, translucent and opaque. Transparent, translucent, opaque. So here what happens is, if I take the transparent object, if light is incident on it, light falls on the object, then light directly passes through. Almost all of the light passes through. Almost. Okay. So I'll show it to you in this way. Right. So you can clearly see I'm showing 3 rays, and the 3 rays are directly passing through. But if I take a translucent object, the 3 rays of light are falling on the object. Then you know what happens in translucent object? In 3, only 2 might pass through, or only 1 might pass through. Let's say this passes through. The other 2 will be reflected back or bounced back. That means they do not pass through. So here light is the complete light passing through translucent object? No. Only partial light. Only a part of light passes through translucent objects. What about opaque objects? If I take an opaque object, and if light falls on the opaque object, what happens is the complete light will be bounced back. It will go back. Light cannot pass through an opaque object. That is a difference, basic difference in terms of what happens to light falling on transparent, translucent and opaque objects. Is that clear? Okay, so by now you should be able to identify what is what. What is luminous, what is non-luminous, what is opaque, what is transparent and what is translucent. Good? Okay, so let's go into a simple question here then. What is the question here? The question is this: substances that allow light to pass through them are called A, B, C and D. Substances that allow light to pass through them are called as what? Anyone? What are they? A, transparent, B, translucent, C, opaque and D, none of the above. What do you think is the answer? The answer will be, they allow light to pass through them, so option A, transparent. Option A, transparent. Good. Next, which of the following bodies allows only a part of light to pass through it? Only a part. This is an interesting question. Options: tracing paper, brick, wood, air. Which of them allows light to pass through them partially, or only a part of light to pass through them? What do you think, everyone? The answer is tracing paper. The tracing paper, like tracing paper is something you use to draw. It will be like see-through papers, right? See-through papers in drawing books. You place the paper on the image and then you draw on it. Right? The same thing, tracing paper. Because you can see brick is opaque, wood is opaque and air is transparent. Air is transparent. Understood? Okay. Next. Is air transparent? Yes or no? You tell me this. Is air transparent? Transparent will mean you can see through it. So can you see through air? Yes or no? Yes, the answer is yes. That means, is air transparent? Yes, it is transparent. Very, very interesting question. Right? Okay. Next. Which of the following is not a luminous object? Sun, moon, candle, glowing bulb. Which of the following is not a luminous object? What do you think? Sun, moon, candle and glowing bulb. And the answer is moon is non-luminous object, because sun produces its own light, candle produces its own light, glowing bulb produces its own light, but moon doesn't. So moon is non-luminous object. Okay. So that's it, everyone. We went into the introduction of light. We looked into how light or how objects behave when light falls on it. Right? So please do practice it. Okay. So thank you. Thanks a lot.